Yes, Assalamualaikum and hi all. So we will continue with the integration, which we will focus on substitution method. Right, so at the end of this chapter or at the end of this topic, you should be able to evaluate integrals by using substitution methods. Okay, so actually there are a few techniques of integration. Okay, the first is integration by substitution, integration by parts, integration by tabular method, and integration using partial fraction. So all these techniques of integration will be covered in this subject. Okay, all right. But for this video, okay, I will focus in integration by substitution. Okay, and for integration by substitution, I split this into two parts. Okay, where the first part is just an introduction, and I have a few example. Okay, and for second part is for another examples. Okay, what is integration by substitution? So this method is the first to be considered whenever we try to evaluate any integrals. Okay, if you have a function that you need to integrate, and if you see from that function you cannot integrate directly, okay, by referring to the table, so the first technique to consider is by substitution. Okay, and the purpose of this method is to transform from the complicated integrand into a simpler, okay, expression of basic integral forms. Okay, and for this method, okay, we have 5 steps. Alright, the first step is to make an appropriate choice of u. Okay, since this is integration by substitution, so we need to choose u, okay, as one function. For example, we have gx. Okay, this is the basic step. Okay, step 2 is from that u, okay, you need to differentiate. Can I repeat? Differentiate. Even though this is integration, okay, but on the second step, you need to compute the du dx, which means that we have choose u, so you need to differentiate that u. Okay. Step 3. Okay. Make the substitution. Okay, we have just now u equal to gx, so we will have du dx equal to g prime x, or we can have dx equal to du over g prime x. Okay. Alright, so after this stage, the entire integral must be in terms of u. Okay, this means no more term in x can remain. Right, so if you substitute all the u, all the dx, so your integration will be in the form of u only, in terms of u. Okay, if you still have x, so you need to change the choice of u. Okay, and then step 4, you just evaluate the integral obtained, but at that time you have just in terms of u. Okay, and step 5, after you integrate, you need to replace back that u with gx. Okay, so the final answer will be in terms of x. Okay, alright, so this is the 5 steps in order to use the substitution method. Okay, let's consider example number 1. Evaluate the following integrals. Okay, we have c over ax plus b dx. So the first step is you need to choose u. Okay, so we have the fraction here. Okay, c over ax plus b. Okay, so you need to choose either u equal to c or u equal to ax plus b. Okay, if you choose u equal to c, next step is you need to differentiate that, right? So if you differentiate c constant, so you get what? 0, right? So if you get 0, so nothing can help you to solve the integration. Okay, so the best choice is you choose u as ax plus b. Okay, so let u equal to ax plus b, and therefore we will have du over dx, which means that we differentiate u with respect to x, you will get a. Okay, alright, so rearrange, because we want to have dx here, we need to substitute that dx. So rearrange these terms, okay, du dx equal to a, so we will have dx equal to du over a. Okay, so now the integration, okay, the original integration will change to new form, alright, where we only have in terms of u. Okay, so c will maintain as c. Okay, c will maintain as c, but our ax plus b, okay, we have changed to u. Okay, because we have this one, u equal to ax plus b. Okay, and then this dx, okay, this dx, okay, will be this one, du over a. Okay, where we get from this term, this equation. Okay, du over dA is dx, and since we have just now abc as a constant, then c over a can be bring to the front. Okay, you can bring out the c over a. Okay, so the integration only left with du over u, right? So to integrate 1 over u du, okay, you will get ln. Okay, so you get ln u plus c. Okay, c over a in front, you just maintain it as c over a. Okay, so you have c over a ln u plus c, and this is not the final answer, but you need to replace u with ax plus b. Okay, so this is the final answer. Alright, so from this example, if we have a, b and c is equal to 1, so the answer will be ln x plus 1 plus c. Okay, so because a, b, c is just constant, so it can be any numbers. Okay, let's move to example 2. Okay, evaluate each of the following integrals. Alright, so we are now in techniques of substitution method, or integration by substitution. So we need to substitute. Okay, the first question, okay, we have exponent for x. We need to integrate exponent for x with respect to x. So what you need to do now? Okay, we have a function. So we know that if you integrate, before this you will have exponent x, integrate, you will get exponent x plus c, right? This is what you need to remember. Okay, but this one is exponent for x. So to apply the substitution method, so we let u equal to what? Okay, we let u equal to 4x. Okay, so if we let u equal to 4x, so we will have du over dx. Means that we need to differentiate differentiate u with respect to x. So we have 4. Okay, and from here we rearrange so that we can have dx equal to what? Okay, so dx equal to du over 4. Okay, why we need to find dx? Because we have this dx, so we want to replace dx with other form, okay, in terms of u. Alright, so now our integration will becomes what? Integrate exponent for x we have replaced with u, and dx we have replaced with du over 4. Okay, and since we have all in terms of u, so you can proceed with the integration. Okay, I just bring 1 over 4 in front. Okay, and I have here exponent u du. Okay, so actually this one is just the same as what is in x. Okay, so integrate that, so you will have 1 over 4 exponent u. Okay, differentiate exponent x, you get exponent x. So integrate exponent x, you will get exponent x. So do for exponent u. Okay, don't forget to put plus c. And remember, the final answer is not in terms of u, but you need to replace back u with for x. Okay, so we have 1 over 4 exponent for x plus c. Okay, so this is the solution for A. Okay, alright, so next, okay, we proceed to example 2b. Okay, we have integration of exponent negative 3x plus 5 dx. Okay, so this kind of question also you can use substitution method, where we let u equal to the powers of exponent, which is negative 3x plus 5. Okay, so you will have du over dx, which is equal to negative 3. Okay, so from here you can rearrange so that you have dx equal to du over negative 3. Alright, and now, okay, we will have the original integration in terms of x, we change in terms of u, we change to u variable. Okay, so we have what? Exponent u. Okay, and dx will becomes du over negative 3. Okay, and then this one, everything is in u, so I can bring negative 1 over 3 in front, so I have exponent u du. So using the same solution just now, integrate exponent u, you will get the same function, which is exponent u, but what you need to replace that u with negative 3x plus 5 and then plus c. So this will be the final answer. Okay, let's move to another example. Okay, evaluate each of the following integrals. Okay, so C, we have the function that you need to integrate is 10x minus 9 to the power of 5 over 2. So this one you cannot use direct integration. Okay, you cannot expand the powers because the powers is 5 over 2. If you have squared, okay, then you can expand it. Okay, but this is 5 over 2. Okay, so how to solve this? Okay, again, this we can solve this by using substitution method, where you need to let u. Okay, we let u equal to 1. Okay, so we only have one choice, which is 10x minus 9. Right, so then we will have du over dx. Differentiate u with respect to x, so you will get 10. And we can rearrange, okay, the dx will be equal to du over 10. Okay, so now, so this integral, okay, can be rewrite as integration u, okay, to the power of 5 over 2. Okay, because this is, we have set as u, okay, the powers will maintain as 5 over 2, and dx will becomes du over 10. Okay, so everything is in u, so we can proceed with the integration. So I bring 1 over 10 in front, so I have u over 5 over 2 du. So integrate this by using the basic properties. So I have u to the power of 5 over 2 plus 1. So you get what? Okay, 7 over 2. So 1 over 7 over 2 as well. Okay, simplify. This one will be 5. So you will have what? 1 over 35. Okay, u to the power of 7 over 2. So that u you can replace as 10x minus 9 to the power of 7 over 2 plus c. So this will be the final answer. Okay. So let's move to the final slide for the first part. Okay. So we have another example which which use the trigonometric as a function. Okay, we have d, okay, integrate sine 15x dx. Okay, so if you have sine 15x dx, if you want to use the substitution method, so you will have you need to substitute u with this one 15x. Okay, so if you have u equal to 15x, what is du dx? So du dx, you will get 15, and you will have dx equal to du over 15. Okay, so this one will becomes sine u dx, where dx is du over 15. So I have 1 over 15 in front. So, and I just integrate sine u du. Still remember? How are you going to integrate sine u? Okay, you get positive or negative? Okay, integrate sine, you will get negative cos u plus c. Okay, so I will have 1 over negative 1 over 15 cos u just now, which is 15x plus c. Okay, right, so this is for D, and the last example for part 1. Okay, here we have integrate cos. Okay, cos where the angle is 2x plus 3. So we let u as the angle. Okay, the angle is what? 2x plus 3. Okay, therefore we will have du dx is equal to 2. And from this you can rearrange dx equal to du over 2. Okay, and now, okay, just bring here. So the integral will becomes cos u dx is du over 2. Okay, so 1 over 2, and then integrate cos u du. So you will get sine u plus c. You will get half sine u just now we have 2x plus 3 plus c. Okay, so this examples for trigonometry. Okay, alright, so that's all for the first part. So we will continue with part 2 later. Okay, thank you.